Thank you. Come to another session of climatology where we shall be moving ahead with the portion of the cyclones. Now, yesterday we have had a discussion about the aspect of air masses, the frontal formation, the concept of a source region, and then furthermore, we moved on into the portion of what do we understand by the cyclones. Now, there we saw that cyclones are basically areas of intense low pressure. Now, wherever you have low pressure, winds will always get attracted towards that low pressure. So you have those areas of low pressure, intense low pressure, not a normal low pressure, very intense low pressure, that we refer to as a cyclone. Now, here you have to understand that there also exists an opposite scenario of that, what we refer to as an anticyclone. So when we say an anticyclone, it is basically the creation of a condition where you have extreme condition or where you have the extreme high pressure. So in a cyclone, you have extreme low pressure. In the case of an anticyclone, you have an extreme high pressure. So from the region of an anticyclone, winds emerge outside and move in all different directions. When we talk about a cyclone, that is the low pressure center. From all the surrounding regions, the winds are targeted towards that low pressure region in general. Now, then we took a look at the different types of cyclonic formation. You have the cyclonic formation, which is observed in the mid latitudes, and that is what we refer to as the temperate cyclones. Now, we have seen that these temperate cyclones are created whenever you have a frontal distortion beyond a certain limit. So not all the fronts will develop into a kind of a temperate cyclone, but for a formation of a temperate cyclone, a frontal formation is a must. It is a prerequisite. Then, after that, we understood the various different stages for the development of a temperate cyclone, where we actually saw that in the case of a temperate cyclone, you have initially the creation of a stationary front, and then you will observe that as the fronts, they start to get distorted. That is when the winds, they start pushing up, be it the creation of a cold front and the creation of a simultaneous warm front. That leads to intense rise of the air. And that intense rise of the air, that creates, now mostly warm air rises, but some amount of cold air also ends up rising up in the process. So that is what we saw as the case of a low pressure, intense low pressure, and there as the air rises, it will develop a circular motion, and that is what we refer to as the cyclonic circulation. It will end up causing significant amount of rainfall. It is widespread over a very large area. We observed that this cyclone will be formed or will be observed mostly during which season? The winter season. And why is that? Because the difference between the warm and the cold air mass is significant in the winter season as compared to the summer season. Now, we also observe that this cyclone will be formed in great majority and in great frequency in the northern hemisphere, because the northern hemisphere is dominated by landmass. So whenever you talk about the temperature contrast, they will always get created in a more exaggerated way in the northern hemisphere as compared to the southern hemisphere. And that is because the southern hemisphere, which is simply dotting or is dotted with a lot of various different water bodies, so, and various different oceans. So in the southern hemisphere, the change of temperature is actually quite uniform in the process. Now, then after that, we looked at the, what do we understand by the end or the dissipation of that temperate cyclone. That is when you have a creation of an occluded front. That is when the front begins to close down from all different sides, and that leads to frontolysis, and that frontolysis leads to the end of the cyclonic circulation in the temperate areas. Now, temperate cyclones will not be observed in the regions such as India or in the tropical areas, because it is observed in the mid latitudes where you have the frontal formation. Then we observed the formation of a tropical cyclone, and we understood the basics of the tropical cyclone in general. Now, in the case of the tropical cyclone, we observed that it is formed over a large water body. That is in the tropics, over the large water body wherever you have seas and oceans in the tropics. Now, in this case, you have to understand that why it gets created is the process is very simple, and the process involves the presence of a very large water body. Wherever you have a very large water body, for example, let's suppose you have a very large water body. Now, once that water body gets heated up beyond a temperature of around 27, 28 degrees Celsius, that is when you have the creation of a low pressure. Now, this low pressure would attract winds from all sides, and the winds that it would attract would also move over the water body, carrying a lot of moisture in the process. Now, as these come to the region of low pressure, these winds will start to rise up. Now, as these winds, they start to rise up. Now, there, it rises up in a circular motion because of the Coriolis force. And as it rises up, it will start cooling down across this spiral, and that creates various different clouds. Cumulonimbus clouds, very dense cumulonimbus clouds are created. That is something that we observed. Now, whenever you have the cloud formation, in a way, it is what we refer to as condensation to happen. So, whenever you have that cloud formation, there is a significant amount of condensation. And whenever there is condensation, so at that point, it will release significant amount of latent heat, what we regard as the latent heat of condensation. Now, because the cooling down is happening around the central region, around the central spiral, that is why all the latent heat of condensation would accumulate in the central portion. Now, in the central portion, you also observe a spiral of rising air. And that continuous spiral of rising air, it creates a central depression or a central sinking, due to which you have sinking of air from the surrounding regions in the center. Now, this ensures that in the central portion, you don't have any cloud formation at all. And also in the central portion, the temperature is comparatively higher in comparison. Now, this subsiding wind or this sinking wind, as it further sinks closer to the surface, it will get heated up. And it will get heated up due to what? Due to adiabatic compression. Now, that adiabatic compression will end up further intensifying the low pressure, which will attract more amount of winds, and the process intensifies, the cyclonic process intensifies, the winds keep on getting stronger, and the longer that this system prevails over a water body, the stronger the cyclonic circulation becomes. So as long as it is over the water body, it continues to generate that heat due to that cyclical process, and that is why this cyclonic process is also what is referred to as a heat engine. The same cannot be said about the temperate cyclone, but for a tropical cyclone, it is referred to as a heat engine because it is able to generate heat on its own. Now, that particular cyclone requires the availability of moist air, and it is because of that reason you will observe that it is formed only over the water bodies. It is never to be formed over the land areas. So how does this cyclone get dissipated? So the moment that this cyclone makes a landfall and this entire portion makes a landfall and comes over to the land, that is when its supply to the moisture gets cut off. And when the supply to the moisture gets cut off, then the process of that heat engine, that gets interrupted, and that is when the cyclone eventually dissipates. Okay, so that is what we had taken a look at yesterday. So today we shall be further developing upon that concept. We shall be talking about how is it that these cyclones, for example, how is it that they make a landfall, whether they are able to create coastal flooding or not, what is referred to as storm surges, how is it that we go for the naming of these cyclones, how are these names arrived at, and then after that, we shall be moving ahead into the portion of atmospheric phenomena such as Enso cycles, El Nino, La Nina, jet streams, Madden-Julian oscillation, Indian Ocean dipole. Now, all of these will help us understand the eventual goal for all of us, that is to understand Indian monsoons in a better way and Indian seasons in a better way. So that is what we will try to get at. Okay. So let us complete the portion of tropical cyclone, few of the cosmetic areas which are left. So one of them is the prerequisite conditions which are an absolute must for the formation of a tropical cyclone. So what are the absolute must conditions for the formation of a tropical cyclone? So here, first of all, for a tropical cyclone to get created, we do require a large sea surface with temperature higher than 27 degrees Celsius. That is a requirement. that the temperature should be higher than 27 degrees Celsius. Why? Because only when the temperature is higher than 27 degrees Celsius, only in that case, you will have a creation of a low pressure. So that low pressure will get created only if the temperature and only when the temperature goes higher than 27 degrees Celsius. Now, then you do need the presence of a Coriolis force. Why? In order to achieve that circular motion of the wind, you do need the presence of a Coriolis force in existence. This is the precise reason why a tropical cyclone will never end up getting created at the region of equator, because at equator we do not have Coriolis force. Coriolis force is zero at equator and is maximum in the region of the poles. So because at equator the Coriolis force is zero, hence no tropical cyclone will get created, because there you can have the low pressure at equator, but there you will have a vertical rise of wind, but not a circular motion of the wind which is achieved. So this is the reason why no cyclonic formation is observed at equator. Or rather than this might end up confusing you that if I'm asking you a question or not. So let's talk about it, that hence no cyclonic formation is observed at the region of equator. So that is why you will never observe a cyclonic circulation to be even crossing the equator, because the moment it comes closer to the equator, it completely dissipates. By the way, we have seen that there is a movement in the case of a temperate cyclone. In which direction do we observe the movement of a temperate cyclone in general? Yesterday we saw that the temperate cyclone also ends up moving the entire circulation. Perfect. It is in west to east because of the influence of the westerlies. Now, what about the tropical cyclones? In which direction will the tropical cyclones end up moving? What do you think? Very good. East to west. That is because the entire circulation will be influenced by the presence of the trade winds. So in the region, you will observe that in both the hemispheres, you have the prevalence of trade winds. So hence, tropical cyclones move from east to west. Okay, under the influence of trade winds. So that is why sometimes what you will also come across is a scenario that a cyclone or a cyclonic circulation might be present here. Now, carried by the trade wind, it crosses the Andaman Sea, enters the Bay of Bengal. Now, the greater the time that it spends over the water body, the stronger it becomes. It becomes much more intense. And hence, that is what will cause a greater amount of destruction. Now, while it is moving from east to west in general, it will also be curving ever so slightly under the influence of the Coriolis force bending as well. Okay, so that is another prerequisite. Then you have another requirement, that is small variations in vertical wind speed, what is also referred to as wind shear. So that basically represents small variation in vertical wind speed, or it basically what it tries to represent is that at various different levels, at various different altitude, the speed of the wind should be almost similar. Okay, so this refers to the fact that at various altitude, the speed of wind will be similar. Okay, the speed of wind movement is similar. Why is that a requirement? Apply your logic here. Imagine if you have a cyclonic circulation in this, as we have seen. So imagine if the wind speed at this level is very, very high as compared to the wind speed near the ground surface. So whatever kind of cloud formation, etc., will be observed, that will be immediately blown away by the wind. So that is why, in order to have the entire circulation develop in itself, you need a small variation in the speed at various different levels. Okay, so that is what you have as the requirement, another requirement. And another requirement is a pre-existing weak low pressure area. So that pre-existing low pressure area, that can further intensify into a tropical cyclone. Now, when is it that a tropical cyclone will dissipate? A tropical cyclone dissipates the moment it hits the land. Okay, so what happens when it hits the land? So we've come to the schematic image of a tropical cyclone. Okay, just a moment here, guys. Observe even this schematic representation. You will find that the cyclone in itself has got various different layers of cumulonimbus cloud, first of all. So understand that you have these various different cloud formations in various different bulks. The clouds are present. These are the individual bulks which will end up causing significant amount of rainfall. They are also hence referred to as the bands of rain, because these clouds, they also arrange themselves in a kind of a spiral manner. Observe this spiral. So in this spiral, you will come across multiple different bands of rain. So why is it that these rain bands are present? Because as the air continues to rise up, it will continue to condense and push the existing clouds to the sides. So that is something which is always experienced. Now observe or imagine, suppose here you have the landmass. Now, if you have the landmass here, and if this cyclone is moving, let's suppose, in this direction, so first of all, that landmass will be impacted by a very strong wind movement, very heavy wind movement, and also very heavy bout of rainfall. And that bout of rainfall will be very intense, associated with a lot of thunder, lot of lightning in the process. But then after some time, the eye of the cyclone, what we regard as the eye of the cyclone, that eye of the cyclone does come and does appear over the landmass. The moment the eye of the cyclone comes over, what do you think will happen to the rainfall? Will the rainfall increase, decrease, or continue to remain the same? What do you think? Perfect. The moment the eye comes over over that particular region, the region does not receive any rainfall. In fact, you have cleared skies for a brief moment of time. For a few hours, you might experience a clear sky. Why? Because the eye is the place where you have the sinking air and also a lot of heat. So, eye is cloudless. You will not have any cloud formation in the eye of the cyclone. This is what is regarded as the eye of the cyclone, and this will end up representing a clear sky. Now that is where many of the people, they mistake it to be the end of the cyclone. They think that the cyclone has basically ended. But that is not the case. Once the eye then crosses over, then the remaining portion, the tail end of the cyclone, again hits with an equal intensity of rainfall, with an equal intensity of thunder and lightning, accompanied by very heavy and strong wind movement. Now, in very rare cases, you will observe. So, in most of the cases, what do we have is the moment the cyclone hits the land, the what will happen, and understand it very logically. The moment it hits the land, now in that case, you will observe what will be the wind speed in that case. Wind speed will increase or reduce when it hits the land. What do you think? Why do you think the wind will increase? The wind speed, why do you think will increase? Or are you simply choosing an option randomly that because, okay. So the moment it hits the land, the wind which was supporting that cyclone, that wind speed will immediately drop. And that is because over the landmass, the frictional force is always going to be significantly and substantially higher. So that is when it will stop its motion. It will not be able to, or it will basically provide resistance to the motion of the winds. So the wind speed reduces the moment it hits the land. So on landfall, wind speed reduces due to increased frictional force. Okay. So immediately the wind speed starts to reduce and reduces quite substantially for that matter. And also the supply of moisture, that is significantly reduced. So overall that low pressure starts to weaken. And that is when you will observe. So whenever, if ever you have observed the news reportage around the cyclonic circulation and cyclone hitting the coastline, you would have observed that continuously the prediction tells you that the cyclone has gotten stronger, stronger, stronger. It is expected to hit Odisha coastline, it is expected to hit Bengal coastline. And the moment it hits the coastline, after few hours you will stop receiving the news reportage about that. You will hear that okay, the wind speed has basically dropped down and the cyclone has dissipated, because that low pressure in itself weakens due to the lack of moisture. Now in very rare cases, what also happens, and understand this, that it is a very rare case. Now imagine a scenario, and let me present to you a situation. Imagine a scenario where, if we talk about the coastline, let's suppose. Now, here, let's suppose a cyclone basically is formed. It moves here, hits the coastline, suppose. Now, if let's suppose already across this region you have an intense low pressure. Now, what will happen to this cyclone in that case? If already you have a low pressure in that region, what will happen, do you think? Will the cyclone get weaker? No. So, in those rare cases, you will observe that the cyclone keeps on intensifying even after it hits the landmass. So, a few months back, you had, or in fact, last year and last to last year, you had a cyclone Tote, which developed. Now, that cyclone Tote made a landfall in the region of Gujarat and Maharashtra, and it got stronger because there was an existing low pressure over the region of Rajasthan and Gujarat. And that low pressure further mixed with the portion of the cyclone, and then it further strengthened into action. Sometimes you also have a low pressure over the land area. So you earlier had, a few years back, you had a cyclone that was Cyclone Titli. Now that Cyclone Titli, after making landfall, it further strengthened in terms of the intensity, in terms of the wind movement that was experienced. Okay, so that is basically a persistent phenomena in general. That is basically not a persistent phenomena, but a rare phenomena in certain situations. Now, this cyclonic event, whenever it happens, you will always associate it with significant coastal flooding. So, coastal flooding is always commonly found in that. Now, why is it that the coastlines get flooded whenever you have a cyclone? So, that has got to do with the wind movement. So, the basic classification done by the meteorological department of the cyclone is based upon the wind speed. And that is where the color coded patterns are also given. You have the green color, you have the orange color, you have the red color. Now that color coded pattern indicates the level of severity of that particular cyclone. So here, when you have the wind speed around 90-95 kilometer per hour, that is regarded as a low pressure, traveling low pressure, or a depression. When it further exceeds around 100-110 kilometer per hour, it becomes a cyclonic circulation, a weak cyclonic circulation, a strong cyclonic circulation, a very severe cyclone, and then you have a super cyclone. A super cyclone is when the wind speeds, they can exceed almost to 20 kilometer per hour. That is what is referred to as a super cyclone. In that case, the wind speeds will be further more intense. Now, when the wind speeds are very intense, now when those strong winds, let's suppose here you have a coastal area, and here let's suppose you have the water body. So here, let's suppose a very strong wind is moving around 200-220 kilometer per hour. Now, in this case, can we say that the wind will end up pulling this water, flooding the landmass? We can say that, right? Because when the wind speed is very high, it will have that dragging effect on the water as well. So due to that, it creates a high amount of surge in water in the coastal areas, leading to a kind of a coastal flooding. That is what we refer to as a storm surge. Storm is basically a very high velocity wind. When you have, we can classify them as storms. So here you will observe when the wind speed is very, very high, it is able to drag the winds or drag some amount of water along with it. It inundates and floods the coastal area, causing significant amount of destruction. So this leads to significant coastal flooding. Coastal flooding is caused. Okay. Two cyclones can, yes, they can get created close to each other, and you can have those disturbances interacting with each other as well. So it happens in larger oceans. Now, it can happen that two circulations, when they come close to each other, it can happen that some portion of it will be dissipated. It can also happen that both of them can mix together and develop into a more intense one. And that is what we refer to as the Fujiwara effect, right? Not relevant for your general studies, but that is what is referred to as the Fujiwara effect. When you have two simultaneous tropical cyclonic storms, when they mix with each other, they further intensify. In many of the cases, they can weaken as well. In general, in Indian subcontinent and around Indian subcontinent, we don't observe that feature quite significantly. Now, if I ask you that as compared to the temperate cyclone, the wind speed in the case of a tropical cyclone, will it be higher or lower? What do you think? When we talk about a tropical cyclone and a temperate cyclone, where is it that the wind speed will be higher? Good. Always tropical cyclone. And what can be the reason for that? Here you have an intense thermal low pressure. Remember, yesterday also we had talked about the fact that when you compare the dynamic pressure systems and the thermal pressure systems, the thermal pressure systems, they are much more stronger, much more persistent. So that is why you will find a lot of wind speed associated. Generally, the size of a tropical cyclone is much smaller in comparison to that of a temperate cyclone, because temperate cyclones, they get created over a very large area of a frontal formation. And that is where you have the temperate cyclones. But the tropical cyclones, they end up getting created over a smaller area. So the diameter in general, if you will observe, the diameter in general will be around 500 kilometers. 300 to 500 kilometers is the entire diameter of it. Okay. So that is basically the features of the tropical cyclone. Now we come to the portion of naming of cyclone. Now, here, before that, when you say the cyclone enters the land, the eye of the cyclone, the entire system entering the cyclone. Okay. So now we come to the naming of the cyclone. But before that, you need to understand why is it that this entire naming phenomena actually began. Okay. Uh, just a moment, guys. There is some technical issue that few of you are facing. So if you pardon me for a couple of seconds, let me get rid of that technical issue and let me then initiate the discussion again. Just hold on for a couple of moments, have patience. So please don't type questions that has the class ended, can we go now, etc. Hold on for a couple of moments. Okay, I understand the excitement that you have with the ending of the class, but no problem to begin with. Do temperate cyclones have an eye? Not all of the temperate cyclones will have an eye. Few of them might develop an eye, but few of them might not. In the case of tropical cyclones, all the tropical cyclones will be developing an eye. Understand, I will repeat that. Not all the temperate cyclones will necessarily have an eye, but all the tropical cyclones will always necessarily have an eye in between. Now we were at the portion of why is it and how is it that the naming was initiated. Well, the tropical cyclones were always provided a kind of a scientific name earlier, and it would be identified with the scientific community and the climatologists. Because in general, in the scientific community, there is always a thought process that what will the common peasants and the commoners do with the naming and that aspect? They are mere mortals, they don't need to know that. That was always the kind of an approach. But it all changed in 1999. In 1999, I'm sure you all would be very, very young in case you were born at that point of time. So you can always ask your older generation, particularly those of you belonging from the coastal state of Odisha. So your older generation would very much associate with 1999 cyclones. So in 1999, what happened was that you had a development of a super cyclone. A super cyclone means a very strong movement of wind was expected in that. And along with that, a lot of rainfall, a lot of devastating power. So, as the cyclone was about to hit, now the government machinery swung into action. And the government machinery basically started announcing. Now, obviously, uh, at this point of time, you can understand the efficiency of the government machinery. So you can imagine what was the condition around 24 years back. So you had a much weaker sense of announcement, weaker case of announcement on the ground level. The administration, they rushed to the various areas and they started announcing to the people to evacuate their homes. Now, generally in our country, the faith or the level of trust in the government is very less. It has increased ever so slightly in the past couple of decades and so, but in general, the trust level is very less. So, when someone from the government comes to your house and tells you that please evacuate the house, there is a storm which is coming, you will immediately look up into the sky and see the sky is clear. This person is clearly foolish and lying, and this person will get me out of my house and maybe grab my house, and my land will be gone, my property will be gone, etc., etc. So that preconceived notion always happens. So that was the case then also. So many people did not evacuate, and those were the years when people did not pay heed to these government announcements. Now they did not evacuate. Few of them did evacuate. Few of them managed to clear the houses. And as and when the intensity of the wind start and intensity of the rainfall started increasing one or a couple of days before the main cyclone hit, people realized that something major is coming to hit the coastline. So people, few of them, they started evacuating, but many of them stayed back. And that is when the super cyclone hit the Odisha coastline. Now it brought storm surge, significant amount of very strong wind movement. Many houses were completely uprooted, trees were uprooted, buildings were shattered, and the loss of life was very, very significant. The destruction cost was very huge. Now, what happens whenever you face a destruction? You can't be angry at yourself, right? You can never be angry at the Almighty God, because the Almighty God can never do anything wrong. You cannot be angry that cumulonimbus cloud has created that. So who will you be angry at? The government. It is the government which has created that kind of uh, a disaster in a way. So that is when all the anger was vented out on the government, that the government had not announced. The government should have insisted that we should basically evacuate our homes, evacuate our houses, etc. The government, and as per the people, the government did not do so. Now, meanwhile, the meteorological department observed that there is a development of another cyclone happening in the Bay of Bengal, and it might hit the Odisha coastline again within a span of 10 days. Now, this time, while there was still coastal flooding and many areas of Odisha were still inundated, and another cyclone was about to hit within a week. Now, this time, the government, both the central and the state government, they started announcing that there is a cyclone coming and it is going to hit the coastline. Now, there the perception was that look at these poor fellows, the government officials. After the cyclone has hit, it has caused all the destruction. Now they are coming to announce it, because that is the general perception that anything that the government does would be delayed in general or would not be efficient. So people did not pay much heed. And that is when, while people were still outside, people were still collecting their belongings. Many of them were still in search of their loved, near, and dear ones. A second cyclone hit the Odisha coastline. And this time, it caused much amount of destruction amongst the larger population which was caught unawares. And the loss of life during those twin cyclones which occurred, it is the unofficial figures claim it to be somewhere around 25 to 30,000 people. They lost their lives in those areas. The coastline, the Odisha coastline, was significantly devastated. Significantly. People lost their all the belongings, they lost their houses, they lost their properties. More importantly, they lost their loved and dear ones who would never return. Now, there a lesson was learned. And the lesson which was learned was that had we identified the cyclone or given the cyclone a particular name, maybe people would have been able to connect with that why or which cyclone is going to hit us. So then you had the countries coming together. In the case of Indian Ocean, you had the countries amongst the northern Indian Ocean who are frequently impacted by the development of a tropical cyclone. They came together, and all of them, they submitted their list of names. Everyone was asked to give a list of names so that the cyclones could be named accordingly. Now, all of them, they submitted a list of names. So you had 8 different countries who submitted a list of names. Now, 8 countries, all of them, they submitted 8 names. So in total, how many names do you have? Good. For a moment, I was scared that I don't know what kind of figure will come up. So you had in total 64 names which were given. Now, all the countries did not participate. You had countries of the northern Indian Ocean, etc., which came into place. Now, here, this 64 names, it started being used, and the various different cyclones started being named based upon this list. Countries were listed in alphabetical order. So, for example, you have Bangladesh, India, and so on. And the names that they gave, that was arranged in rows. All of them, the names that they gave. So one by one, a name was picked up from the list, and that is how the cyclones were named. It was understood, or it was a kind of an understood aspect, that if any cyclone ends up claiming a large number of lives, then that cyclonic name will be struck off, never to be used ever again. But then how is it that the naming would be done? So in each of the tropical oceans, you have a regional specialized meteorological center, and what is referred to as an RSMC, and a TCWC, that is a tropical cyclone warning center. Now, immediately as a low pressure starts developing, the tropical cyclone warning center gives or issues a warning that a cyclone is about to be created. That is something which alerts the RSMCs, that is the Regional Specialized Meteorological Center. And the RSMCs, basically, that is where it is picked, a name is picked from that list, and that is given to that particular cyclone. So that is how the cyclone naming is done, especially in the case of the Northern Indian Ocean, is what we are talking about. Now, in the month of April, last week of April and first week of May 2020, the 64th name in that list, that was Cyclone Ampan, which was provided by Thailand, that was used. Now, obviously, all these countries came to know about it earlier itself, that the naming list is going to get exhausted. So that is where a couple of years prior to that, all the countries of the Northern Indian Ocean, they sat together again. Just the previous phenomena was repeated again. And this time, 13 different countries came together. And all these 13 countries, all of them, they provided 13 names. So how many in total names do you have? Good. Thank you. 169. So in total, 169 names were submitted. And presently, since May 2020, this new naming list is being utilized. So what happens whenever a low pressure center is created? That TCWC gives a warning and alert that a cyclonic circulation is developing. It will give you an idea about what kind of cyclonic circulation, whether strong, weak, etc. What is its movement? What is its expected path? And then after that, the RSMC takes over. So across the globe, you have various different RSMCs. For example, what do we refer to the tropical cyclones developing in Atlantic? What is it referred to as? Hurricanes. Very good. So the naming of hurricanes is done by RSMC Miami, which is in Florida. And also you have RSMC Honolulu, RSMC Nadi, RSMC Tokyo, RSMC Reunion Islands, and also RSMC New Delhi. RSMC New Delhi, that is the Regional Specialized Meteorological Center of New Delhi, that is responsible for the naming of the cyclone which develops in the Northern Indian Ocean, be it the Arabian Sea or the Bay of Bengal. So cyclones will develop both in the region of Arabian Sea and Bay of Bengal, and they are named by RSMC New Delhi, which is actually an office in the Indian Meteorological Department building itself. That is where the RSMC is. So it picks up a name from that list. So what is that list we are talking about? So you have this as the list where you can say, or you can see that you have 13 countries. Okay. 13 countries, all of them gave 13 names. I have attached only 2 names for each countries, but this list goes on for 13 countries. And one by one, a name is chosen and a cyclone is named in the process. So here you would observe that the cyclone which occurred recently in the case of the Arabian Sea was named as Biparjoy, right? Now that was a name provided by Bangladesh. Now the next cyclone which is going to occur, be it in the region of Bay of Bengal or be it in the region of Arabian Sea, it will be named as Tej. And the cyclone which will be observed after Tej, be it in Arabian Sea, be it in Bay of Bengal, anywhere in Northern Indian Ocean, it will be named Hamoon. The cyclone which will occur after that will be named Midli. After that, Michong, or what is Migjom. So this is the pronunciation of that name that each countries have provided. Then you have Remal. Then you have Asna. So like that, a name will be picked up from the list. So the next cyclone, wherever it will occur, will be named as Tej, and that is a name given by India, then Iran. So all these countries are arranged in an alphabetical order. Okay, there are 13 names in total. I have only given you the list of these 2 names because compiling that 169 names in the screen obviously becomes impossible. So I hope you understand. Okay. So all those who are asking why only two names, is it something that you have omitted, etc., etc.? No, I could not compile the entire list of 169 names in the same screen. If I would have done so, then obviously the complaint would be that it is not visible. So better to have the two name list so that you get an idea. But just to give you an idea, similarly, you have column 3, you have column 4, you have column 5, and so on, column 13. Okay. Okay. So let me ask you a general question based upon the questions that you are asking. Do you think UPSC will ask a question from this in prelims? If I give you a question, or if I put you as a question paper setter, frame a question from this name list if you can. Surprise me. That what will be the question that you will set? Will you set that list out all the names given by India? Or would you set a question that what do you think would be the cyclone which will be, or the name of the cyclone created after 5 different cyclonic events? You cannot frame a question from this, can you? So please apply that logic. If I tell you that all these 169 names are important for prelims, would you start learning all those 169 names? Please don't do that. Please start applying your logic, guys. Okay. So please understand, when you have that kind of a question in your mind, so I see many of you, the question is, how do you think, if UPSC is, do you think that UPSC, the question paper, the person who is setting the question paper, do you think that person is running out of the areas where they can ask a question? If they can go ahead and ask a question about the fact that whether orangutan uses a stick to eat ants or not, or whether a honeybee by fluttering its wings can give an idea about where the food is, do you think that person is running out of questions, that that person will ask a question from this? And do you think that person will ask you what is the next cyclone being named as? And imagine after he has set the question paper, Tej has occurred. So the answer will also change. Maybe after the question paper has been set and before the exam is held, and by the time that the copy is evaluated, 2 more cyclones have occurred. So the answer will change. So always apply your logic here. Not only for geography, always apply your logic across. So that is what I tell to everyone, that all those who come to us and come to me particularly, that should I start learning all the various national parks and wildlife sanctuaries? So you have 108 national parks, around more than 500 sanctuaries. Will you be able to learn all of them? Even if I say that go ahead and learn all of them, will you be able to do so? So please understand, hold your horses. This is not going to happen. This kind of a question won't be asked in your prelims. But UPSC asks the question about the general principle of naming. How is it that the naming is done? That is a question which UPSC has asked significant number of times in the mains exam, both for the general studies and the mains exam. And when both in the general studies and the optional preparation. And whenever UPSC has asked this exam, UPSC does not expect you to reproduce that list. Maybe if you start reproducing that particular list, maybe UPSC will have a doubt that you must have cheated. Because even I don't think Indian Meteorological Department, any official you call, even they won't be able to recall you 10 lists or 10 names out of that list. So temper down your expectation of yourself that you will be able to learn all of them. Okay. Right? Understood? Good. So that is basically the aspect of the portion of the naming of the cyclone. That is how the naming is done. Is this understood? The aspect of naming. Good. So initially what happens? You have a low pressure which develops. TCMC is the one which tracks the low pressure. It talks about the development of low pressure. It alerts the RSMCs. The RSMCs further track that, and then the RSMC will give a name picked up from the list. Which list? The list of the countries that they have given. So the countries, they are arranged in an alphabetical order, and their names, they are arranged in a row-wise pattern, and one by one, that name is selected. Any particular cyclonic name which has caused a lot of deaths and destruction, that name is struck off, never to be utilized again. Is that understood? Good. World Meteorological Organization. So, whenever you have any global meet or any global meeting about the impact or climatic conditions in general, World Meteorological Organization will be involved. So, under the aegis of World Meteorological Organization, that is where all these countries they came together. Okay, right? Mayank, the cyclone in Japan, you have a different list for the typhoons as well. But obviously, you are not supposed to know about that. Once you start preparing for the administrative services for there, maybe they will ask you, but not in that case. Why China is not included? Because China is not impacted by the cyclone in the northern Indian Ocean, is it? China will be impacted by the typhoons. Okay. Now, similarly, you have the naming list for the hurricanes as well. And understand, similarly, you have the naming list for the typhoons as well, Willy Willies as well, all of them. Now, because of global warming, the warming of the seas has been happening at an incredibly fast rate, due to which the frequency of these cyclones has been increasing at a very, very fast rate. And that is where you will observe that basically, as they are happening very frequently. So, in the case of the hurricanes, the RSMC Miami actually ran out of the naming list. That is when past year they started naming the hurricanes based upon the Greek alphabets. So you would have heard in Atlantic Hurricane Alpha, Hurricane Beta, Hurricane Gamma, Hurricane Delta, Hurricane, all these were based upon the Greek alphabets because they started running out of names. Okay. Now, after this, we talk about the difference in the tropical and temperate cyclones. So tropical cyclones, they move from east to west under the influence of the trade winds. Temperate cyclones, they move from west to east. Now, a tropical cyclone has an effect on a comparatively smaller area as compared to a temperate cyclone. Velocity is much higher and more damaging. It will form only over sea, but it can be formed both over land as well as sea. It doesn't last for more than 7 days, where temperate cyclones can last for 15 to 20 days in general. Okay. Now I understand. Will they use the same list in Japan? No, my dear friend, they will not use the same list in Japan. There are different aspects or the different list for the typhoons, which is there. Okay. Now I understand few of you have a couple of questions, and a couple of questions in the sense that why is it that more cyclones occur in Bay of Bengal? That is a question which I'm sure many of you have, because you would have seen it somewhere. That is why you know that there is more cyclone in the region of Bay of Bengal, and you're curious for that answer. I understand that. Again, I would say have patience for the few modules, and over the next few modules, over a period of time, we shall be developing the concepts with the help of the oceanic studies as well. When we study the oceans, that why is it that more cyclones occur in the region of Bay of Bengal as compared to Arabian Sea? Because if I recount you the reasons right now, you won't be able to understand, because we have not covered the portion of Walker circulation, we have not covered the portion of stratification of ocean, we have not covered the portion of La Nina, we have not covered the portion of Indian Ocean dipole. So as of now, you will not be able to gather the input of why more cyclones occur in the region of Bay of Bengal. And second question that you would have, many of you have asked that question, is that why is it that the cyclone hits the Gujarat and the Maharashtra coastline? Again, I will tell you about the cyclonic season, which occurs in India when we talk about the Indian monsoon and the Indian climate. I will tell you about the cyclonic season. I'll tell you that why is it when I say that the tropical cyclones move from east to west, why is it that in cases of Indian coastline, you observe the cyclone to move like this or like this. So that is again attracted or due to the movement of the wind and the wind direction in itself. So we will come to it, and you will have a better clue about it when we talk about the Indian seasons, which we will be talking about tomorrow Indian monsoon is something we'll be talking about tomorrow. You will understand that. Okay, right? Good. Diameter of tropical cyclone, we have already said, is around 500 kilometers at max, 300 to 500 kilometers, whereas the diameter of a temperate cyclone can be 750 to 1000 kilometers. Now, then we come to the portion of effects of air masses on climatic conditions. What are the impacts of air masses on climatic conditions? So, first of all, they would be influencing the temperature. How? By advection process, isn't it? So you have warm air mass creating a warmer condition in a region, cold air mass creating a colder condition in a region. So here you will have due to the process of advection. Okay, warmer air raises the temperature and colder air reduces or decreases the temperature. Okay, now then we have also the impact of air masses on climate in terms of precipitation. So when we talk about precipitation, so either due to frontal formation or even sometimes when you have the maritime air masses coming over to the land area, that will also end up creating precipitation in the process. So either due to frontal formation and also influence of maritime air mass. Okay, so both will impact the rainfall. So if a question is asked about the effect of air masses on climate, you have to talk about it, that the temperature will be impacted, the precipitation pattern will be impacted, and there you cannot simply say frontal formation. You have to also elaborate that you will have a different kind of weather condition in the case of a cold front. You will have a different weather condition that we have discussed in the case of a warm front. What is the weather condition that we expect? Both of them you have to elaborate. Then this also ends up creating cyclones in the process. So air masses, they can create temperate cyclones when you have a front formation, and also when you have moist air masses, warm and moist air mass, that ends up creating tropical cyclone. So I would suggest to you very heartily and rather request to you that the portion of temperate and tropical cyclone, rather than directly looking at any book, you are free to explore any book that you want, even though I have given you that always take a look at the very basics, that is the NCERT if possible. So whichever book that you like, take a look at them after you have understood them from the lecture. So please revise their entire formation, their development, their dissipation from the lecture. Build up your concept. Try to write it down in your own words step by step. Just looking at the image, many of us, when we carry out a revision, we simply stare at the pages. And we have a kind of an expectation that whatever information is there, by looking at it, it will start flowing through a kind of an invisible highway into our mind. That does not happen. That is where a few of you have also sent a mail that I understand the concept, but I'm unable to write an answer. That is because you are understanding a concept. When you are understanding a concept, try to write it down in your own words. That is when you will understand the glitches in your level of understanding as well. So once you revise it, try to recreate it in your own words step by step. Imagine as if you are creating an answer there itself. And after that, that will be your notes. Use that for revision. Trust me, you will not find that kind of simple explanation in any particular book, and that is for surety. So if the concept is clear here, you will never forget the portion of either temperate or a tropical cyclone. Okay. Now, after this, we will discuss few of the main type of questions associated with this. So later on, but now we come to the portion of atmospheric phenomena. Okay. Now, here, when we talk about the atmospheric phenomena, this is relevant both for your prelims as well as mains examination. So what is it that we are going to study here? So here we are going to use, or we are going to study about Walker circulation. We are going to study about Enzo cycles. We are going to study about Indian Ocean dipole. We are going to study about Madden-Julian oscillation. And we are going to study about the jet streams. Now, please understand that out of all of these, this is something, Madden-Julian oscillation is something that the meteorological community in itself has not gotten an entire grip about it till now. So this is under still a lot of investigation, a lot of research. This is something that we got to know only a couple of decades back, or 3 to 4 decades back. That is when we got to know about it. So there is still a lot of research going on about the impact and the formation of that Madden-Julian oscillation. But that is where this always forms a part of your current affairs information that you get. So here, in all of this, you should be aware of what they are, the basics of them. They will never ask you in the prelims about and go into the depth of it. Just the basics of them is something which should be understood. So for your prelims, what is relevant out of here is Walker circulation. It is relevant to know about El Enzo cycles, that is El Nino, La Nina, what are they? Then basics of IOD and also jet streams. For the mains examination, out of this, jet streams are the important one, and Walker circulation is something which can be asked in the mains examination. In optional areas, for the optional paper, they will ask you in detail about the Enzo cycle also, but not in the general studies portion. Okay. So that is basically the area that we are going to cover in this particular atmospheric phenomena. Now, I had asked you yesterday before the end of the session to go through the revision of the permanent wind system as well as the region of the Pacific and the Indian Ocean. I expect that at least that basic thing you would have carried out. The permanent wind system, what are trade winds, what is eastern part of Pacific, western part of Pacific. I hope there is no doubt in that. Right? So that is what we will be utilizing as we move ahead. Okay. So here, when we move ahead, first of all, we talk about the very basic of the rise and fall of air. So when we talk about the influence of temperature on the rise and fall of air, let's suppose due to influence of temperature. Now, what do we observe? A region which is warmer. Let's suppose this is a region which is warmer. Now, in this area, because it is warm, you will have creation of a low pressure, and that low pressure will attract winds from different directions. The wind will rise up, then it will diverge. As it diverges, it will sink in a region of a high pressure or create a high pressure wherever it sinks. There it diverges again, and that is how the circulation is achieved, isn't it? That is what we have basically taken a look at. Now, all these areas that we have considered in terms of the various different pressure zones, etc., we have basically observed that the circulation pattern of the wind is between different latitudes. We have seen that the air circulation happens between different latitudes. Now, a region which is as wide as the Pacific Ocean in itself. Now, around the region of equator, the Pacific Ocean is going to be significantly wider. Okay, so there is always going to be a condition that one portion of the Pacific warms up at a different rate as compared to the other portion of the Pacific. And that can induce a circulation at the same latitude. Now, this is something which for the first time in the late 1800s struck in the mind of Gilbert Walker, or what you can also refer to as Sir Gilbert Walker, who was a great climatologist and meteorologist in his own scope. Sir Gilbert Walker was absolutely convinced that this circulation of air need not necessarily happen between different latitudes. In a region such as wide as the Pacific, it can end up happening across the same latitude, in between different longitudes, but across the same latitude. He was absolutely convinced about that. So that is where he further carried on the investigation of that. And he actually came upon a finding that there indeed is a circulation going between the eastern and the western part of the Pacific at the same latitude due to different rate of heating of both portions of the Pacific, aided by the wind movement, etc., which we will see. But he was convinced that there is a movement of the wind happening at the same latitude across both the regions of the Pacific. Now, that circulation was named as the Walker circulation after Gilbert Walker. Now, Gilbert Walker even was convinced that a same event of the circulation in the Pacific would also end up having an influence over Indian monsoon. And Indian monsoon has always been like an enigma. People have tried to understand Indian monsoon very significantly, and a lot of energy has been invested. Now, even now we don't completely know, we cannot say that we know it 100% about how the monsoon is about to behave. We can only do the post-mortem, in the sense that some region in India receives excessive amount of rainfall, and then you will see the meteorological department come up with a statement, you know what, this region actually had to receive greater amount of rainfall because of these conditions. Now, they do not know it one day in advance, or they are not able to predict it 1 week or 1 month in advance. Mostly, we are still trying to know more about monsoon. Now, Gilbert Walker was very much convinced that this kind of a circulation can have an impact on Indian monsoon as well. That is when he took his transfer, he came to Indian Meteorological Department. In fact, for a few years, Gilbert Walker was also at the head of the Indian Meteorological Department, obviously in the early decade of 1900. But till he was here, he could not contribute significantly in his researches. It was only later on that an impact was understood on the Indian climatic conditions and the Indian monsoon created due to these circulations. So first of all, we will try to understand what is this Walker circulation? Why does this happen? And then from there, we will have the deduction of what do we mean by El Nino, what do we mean by La Nina, and why does this happen? So here, before going into that, I want you to focus upon the basics of oceans for a minute. So when you have an oceanic water, I'm talking about the warmer region, the tropical region. What is the source of heat for the oceanic water? What is the source of heat? Perfect. Solar insolation. Solar insolation is the prime source of heat for the ocean, especially in the tropical areas. Now, if the solar insolation is the prime source of heat, now if I ask you, if we have arrived at that conclusion, if I ask you, out of the place, let's say A, and the place, let's say here B, which of them will indicate a higher temperature, A or B? A, always, right? A will always indicate a higher temperature because that is where more amount of solar rays will be received, and B will indicate a colder temperature because it is at a depth of water. As you start going into the deeper regions of the water or the ocean, it keeps on getting colder and colder. So A will be warmer. So with this, let us have a couple of conclusions at the get-go. So, first conclusion. In the tropics, the surface is the warmest or hottest layer. The subsurface is comparatively colder. Okay, I hope you don't have any doubt up till now that the subsurface will be comparatively colder because the surface is the warmest layer that is present. The surface is so in the tropics, the surface is the warmest and the hottest layer. And then why? Because that is the region where you have maximum intensity of the solar rays received, and the subsurface is comparatively colder. Okay. Now, if let's suppose I have a very strong wind movement. Now, in general, we have seen that the speed of wind movement overseas over the region of the water bodies, that is higher because the frictional drag, the frictional resistance is less. So that is why the wind, when it blows over the seas, it will blow with a very high speed, very high velocity. There is nothing to oppose the wind movement. So in general, over water bodies, the winds, they start getting very, very strong. Now, as the wind blows here, now can we say that the wind will start to carry with it some amount of surface water? So when you have a very strong wind movement, so it carries the surface water along with it. Perfect. Yes, even maybe from your side would be fine for me right now. As of now, even maybe is okay for me. But can you imagine a situation where that strong wind movement is going to drag the surface water along with it? Now, when the wind movement is going to drag the surface, so in this region, let's suppose we consider it here, the warm surface water has been dragged away. So what will you have? Either you can have a depleted water region in that case, or you can have the subsurface water coming to the surface and replacing the portion which has been dragged. So what do you think will happen in that case, in the sense of what do you think will be the change in temperature on the surface? So as the warm water is carried away, the subsurface water rises up to replace that, and subsurface water is cooler. Subsurface water is colder because generally water level ends up remaining similar, right? So we can say that wind movement carries the warm surface water. Subsurface water replaces it. Till now, I hope no doubts till now, isn't it? I hope till now there is no doubt present. Now, let's suppose here I have a landmass or any kind of obstruction which is present. Let's suppose here I have a landmass or any kind of obstruction which is present. Now, all this warm water will get accumulated here by the wind, and eventually the water has got no place to go. So the water will be pushed down. It will start accumulating here. So this becomes a region for warm water, accumulation of all the warm water that the wind has carried with it. And in the meanwhile, the colder waters, they rise up in this region, and this becomes cold. This becomes warm. Comfortable up till now? Now let us proceed and implement this scenario in the portion of the Pacific, and then I'll give you the definition of the Walker circulation as well. Don't worry about it. So let us understand what actually unfolds in the region of equatorial Pacific. So if you consider the region of the Pacific, first of all, draw the equator. This is your equator. Okay, I'll write it down as well before someone asks me what this line you have drawn. So this is equator. Okay. Now, around this region of equator, which kind of wind movement will be observed? Is this list is important for prelims? Which list are you talking about, Ashay? Are you talking about the cyclonic list? Then it is not important for your prelims. So here, which kind of winds will be prevalent? Trade winds? Good. Easterlies, yes. So trade winds in general will have a pattern in both the hemispheres, will exhibit a pattern somewhat like this. Okay. Now, if I were to consider only the equatorial region and not the tropical area, let's suppose I consider the fragment of the wind only in the equatorial area. Now, what can we say about the direction of these winds? These are trade winds. Okay, so these are your trade winds. So what is the direction of the wind? Can we say around the region of equator, the general flow of direction is from east to west? Right? We can say that the general flow of direction is from east to west. So these wind, the wind movement will be east to west. Wind movement in equatorial region is east to west. Okay. Now, after this, here, if the general wind movement is from east to west, my photo is not clear. My voice is clear. My voice is audible. Is my voice clearly audible? Perfect. Then you can, I hope you can adjust with the blurred photo anyways. So that is where The general motion is from east to west. Now these winds, they will be dragging the surface along with them. They will be dragging the surface water along with them, isn't it? So as the surface water is dragged, surface water is the warmer water region. Now it will be dragged up till what extent? Up till the region where they face an obstruction. So all this warm water from the surface will be dragged and will get accumulated somewhere here. That is, accumulated warm water will be present here, isn't it? Now, if the accumulated warm water is present here, what will happen in this region where the water has been carried away? What will be the temperature condition of water in this region? Cold water moves up, cold water rises up. So this will be colder region. Water here will be colder, isn't it? So here you have the warmer waters, the accumulated warmer waters. So let's say here you have accumulated warm waters. Warm water. Here let's suppose you have cold subsurface water. So there can be a creation of a thermal pressure zone here where you have accumulated warm water and a colder water. There can be a thermal pressure zone created. So now tell me, what will be the pressure in this region where you, in the Western Pacific, what will be the pressure? Perfect. You have low pressure here. So this is a region of low pressure. What will be the pressure in this region in the Eastern Pacific? High pressure, comfortable. High pressure, winds always blow from a high to a low. Now here already you have the presence of the trade winds, so they can get strengthened. So here you will observe that this low pressure starts attracting winds from the high to the low. Now as the winds come here at the region of equator, what do you think will happen? The winds, as they come and converge around this low pressure, where will they go? Will they go to Japan? Will they go to Australia? Where will they go? They will rise up. Simple, right? They will simply rise up here because the wind will also get warmed up. They will rise up. Please don't think about it that the wind is going to Japan. Don't think about it. I'm here indicating that the wind is rising up. So the wind or the air rises up. After rising up, in this entirety of the region, it will form dense clouds. It will cause copious amount of rainfall in the region of North Australia, in the region of Indonesia, Philippines, etc. It will cause rainfall. The wind further then diverges around the region of tropopause. One portion goes here. Now we have sinking air in the region of the high pressure. So can we say we have an air circulation which is achieved? Can we say that an air circulation is achieved across the same latitude? Not across different latitudes, but across same latitude? And this circulation is between different longitudes this time, at the same latitude between different longitudes. Are we comfortable with this portion, this basic portion? Perfect. This is what is your Walker circulation. As simple as that. That is what is referred to as a Walker circulation. So when we talk about a Walker circulation, It is the longitudinal east to west circulation across the equatorial Pacific that is known as the Walker cell or the Walker circulation. Okay, I hope that is understood, right? So here is the condition that you will observe. So this is your region of Eastern Pacific. So across the Eastern Pacific, no, this is not your Hadley cell. So across the Eastern Pacific, you will observe that as the trade winds blow, observe how they are carrying the warm water. The warm water accumulates here across the region of Australia, North Australian coastline. And that is where it will rise up, form the convective clouds. A circulation is achieved between high pressure and low pressure. Here the cold subsurface water will rise up, creating a high pressure. Here you will have low pressure. So that is your Walker circulation. Now, before you start getting confused about what is this WX, so that represents fair weather, because in the region of high pressure, you don't experience rainfall. So that is why you have fair weather. And here you have lots of rainfall. This is the Darwin coastline. This is the Tahiti. Tahiti is basically, where is Tahiti? Tahiti is in this region of Central Pacific. Yes, perfect. So that is the representation of Walker circulation. So first of all, understand the chronology. Trade winds blow from a general direction of east to west. The winds blowing over the vast expanse of the Pacific gain a higher speed. When they gain a higher speed, these trade winds tend to drag some amount of surface water along with them. Now, those surface waters, they are warmer due to solar insolation, isn't it? So that surface water is carried. Now, these warm waters accumulate. That creates a condition of low pressure where? In the region of Western Pacific. Okay. I hope this is clear. Up till now, I hope this is clear. Right? Now, then we proceed further with the aspect of when we talk about this Walker circulation. Understand, this is as per NOAA or United States climatic agency that you have, which keeps a track of the oceanic and atmospheric temperature and movements in general. So here you will observe that you have a kind of a high pressure created in the region of the Eastern Pacific, a low pressure created in the region of Western Pacific. That low pressure is something which is very large, and it causes very significant amount of rainfall over Indonesia, over northern Australia. Whereas the Peruvian coastline, that is, where is the Peruvian coastline? The Peruvian coastline here, the region of Eastern Pacific is where you have the Peruvian coastline, isn't it? The East Pacific. So Peruvian coastline, will it receive rainfall or will it be dry? What do you think? It will be dry. So that is where, under normal conditions during these times, the Peruvian coastline is drier, and there you have the circulation. So this rises up further. It diverges in the region of the tropopause. One goes towards the region of the Eastern Pacific, other goes towards the region of the Indian Ocean, and then it sinks, creates a high pressure in the region of the Western Indian Ocean. Okay, creates a high pressure in the entirety of the region of the Western Indian Ocean. So that is what you have as a Walker circulation. Okay. Now, if I ask you another question here, you have a sinking air. This is something which is prevalent under normal conditions. This is something which is present in the normal conditions. Now, when we talk about the region of Arabian Sea and Bay of Bengal, I hope you are able to see in the map, which area is more prone to develop a tropical cyclone in these conditions? Arabian Sea or Bay of Bengal? Perfect. Very, very good. It is Bay of Bengal. Why? Because the Western Indian Ocean here, it has developed a high pressure. So for a formation of a tropical cyclone, what is it that you require? a pre-existing low pressure system. But here you have a high pressure. So there are chances of a pre-existing low pressure system maybe traveling from here or maybe developing here, but it will not develop easily in this region. So even under normal conditions of Walker circulation, you have conditions ideal for a cyclonic formation in the region of Bay of Bengal. Okay? Now let us build up on this particular concept and let us try to understand the aspects of ENSO circulation. Before that, we will take a look at the up feature of upwelling and downwelling. Now, this is something associated with the portion of oceanography. Now, let's suppose we consider a then how come Biparjoy occurred in Arabian Sea? Time and time again, I have told you, please have some patience. Biparjoy has occurred. Let me tell you, Biparjoy has occurred because this year you have an El Nino condition, and to add on to that, you have a condition of a positive IOD. And as you already had an existing low pressure cell created by the movement of ITCZ at that point of time over the Indian subcontinent, so that always attracted the low pressure formed over the region of Arabian Sea towards the ITCZ, due to which that Biparjoy, which was created due to the warming of the Arabian Sea, got attracted by the ITCZ, and that is when it hit the western coastline of India. Did you understand that? No? That is why I told you, please have some patience. I will not go without explaining everything to you. Everything will be crystal clear. Just have some patience. Is it that tonight you have to write somewhere that why Biparjoy occurred? I hope tonight you are not appearing for the exam. All I'm asking you for you is one day. Wait for one day. I will tell you why that cyclonic circulation happens in the region of Arabian Sea, why that heating happens, why there is a recurving, why there is a motion in the northward direction of the cyclone, what are the cyclonic seasons. I will tell you the details of each of them if you want to understand. If you simply want to listen to this and you have already studied about it, then there is no point having all of that discussion anymore. Okay? Right? So, let us consider the land areas here. Let us consider these land areas and let us consider a larger oceanic region. Now, this is not what I know it appears like a case of a bathtub, but it is not your traditional bathtub. Let's assume that this is what represents your ocean, and let's assume this represents your continents. Okay. Now, we have seen that the surface will be the warmest region because of heating, because the source of heating is the sun, and the sun ends up heating the surface significantly. So here, when you have the movement of the wind, let's suppose in this direction, let's suppose you have the wind movement. Now, if the wind movement is in this direction, which kind of wind will it be, onshore or offshore? This can be regarded as an onshore wind or an offshore wind. Offshore wind, right? Onshore is the one which moves from sea to land. Offshore is from land to sea. So this will be your offshore wind movement. Now that offshore wind will carry the surface water along with it, isn't it? That surface water will be dragged along with it. Now, as the surface water is dragged, what do you come across? We have seen that the subsurface water rises up, right? Now, that subsurface water, when it rises up, it is an upward movement which will happen. Now, what will be the impact on temperature on the surface in this case? The temperature would reduce. the temperature would reduce. It would become colder, right? So the upward movement of the subsurface water creates the colder conditions. Colder surface water is created. So this upward motion which is created when the surface water is dragged away, you have an upward motion of the subsurface water. That is referred to as upwelling. I'll provide you with a detailed definition of it as well, so please don't worry about it. As of now, just try to visualize it. So as the surface water is dragged by the wind, it will expose the subsurface water which will come to the surface, and that makes the temperature colder. Now here, this particular warm water, this particular region of warm water, now it will be dragged by the wind, but till where? Till the coastline. Now after reaching the coastline, this keeps on getting accumulated. Maybe some increase in height will happen, maybe by a few centimeters, but it will keep on getting accumulated. Now, as more water is brought about, can we say that eventually this will be forced or pushed down deliberately? That will not be a natural movement of water, but somehow it will be pushed down, isn't it? Right? Can we imagine that scenario? So here, when you have a forced downward movement of water which is happening, that is what we refer to as downwelling. So when we talk about, and we'll talk about it again in oceanography when we come about it. So upwelling, what is the impact on sea surface temperature? It cools the sea surface. And downwelling, what is the impact on sea surface temperature? Warms the surface. Okay. How the water will be pushed downwards? Because it is consistently being brought, more warm water is being brought. So the water has got no other place to go. So deliberately it will be pushed down. Why it will not spread over the coastal area is because the winds are not that strong to carry that water, elevate it over the coastal areas and carry out that flooding. So it will be consistently moving over and eventually the water will be pushed down. So that is what is referred to as downwelling. So you have, that is the case of upwelling and down. Now upwelling is sometimes significantly, or in majority of the cases, it is very beneficial. When it comes to the marine biodiversity, upwelling is significantly beneficial. Why? Because the seawater, I hope we are aware of the basic fact that the seawater consists of many nutrients, many different dissolved salts present in them. And those dissolved salts, generally, they are present at a lower level. They are not present at the surface. They are generally present at the lower level. Now, whenever upwelling happens, all those particles, the nutrients, iron particles, etc., they are brought closer to the surface. Now, when they are brought closer to the surface, so you have availability of nutrients closer to the surface. Closer to the surface, you will also have availability of sunlight. So under those conditions, you have growth of algal species such as phytoplanktons. Phytoplanktons, they start to grow. Phytoplanktons, you will study in the portion of environment and ecology as well whenever you will attend the sessions, that phytoplanktons form the base of the marine food chain. These are green algal species. Now, these phytoplanktons, which are green algal species, they utilize sunlight, nutrients, and they are able to carry out photosynthesis. These are microscopic algal species. So they carry out photosynthesis. So that growth of phytoplanktons in many of the cases turns the water slightly greenish as observed from the satellite data. Now, when these phytoplanktons come closer to the surface, The zooplankton, slightly larger algal species, they will start consuming. Their population will increase because as the food increases, the population of zooplankton increases. Phytoplankton is the food. They have the ability to manufacture their own food. So phytoplankton population increases, zooplankton population will also come to a rise. Now zooplankton population rises up. The small fishes, they will also start increasing in number. When the small fishes increase in number, larger fishes number population will also increase. So these end up forming very good fishing grounds in general. So upwelling, wherever it happens, it is good for fishing. So in the case of the Walker circulation, where is it that upwelling happens? In the case of Walker circulation, upwelling happens in the region of Eastern Pacific Ocean. Okay, across the Peruvian ocean surface, they push the water away. Water then rises up from beneath the surface to replace the water that was pushed away. This process is known as upwelling. Upwelling occurs across coastlines or sometimes across the open ocean as well, wherever you have the wind pattern. Now, the reverse process called downwelling also occurs when wind causes surface water to build up across a coastline and the surface water eventually sinks towards the bottom. So, upwelling is beneficial for fish population. How? Increases the population or growth of phytoplanktons. Okay? That is the aspect of upwelling and downwelling. So after this, we move on to the portion of enzocycles. But before that, we take no, it will not happen across a river. No, it will happen across the oceans. So after that, we'll move to enzocycles. Before that, we take a break, and then we come back and we continue again. So we take a 10 minutes break, and we'll be back in 10 minutes. Have a creation of a low pressure and a high pressure system. So the air circulation that we studied earlier, that from the region of the low pressure, the air will rise up, it will diverge upon hitting the troposphere, tropopause, and then eventually in the region of high pressure, that is where the air tends to sink, and that is why you have the condition of a circulation. Okay. Downwelling also happens in the region of the low pressure. Yes, downwelling, that is what will create a kind of a warmer area. Ananya, in most of the cases, yes. In most of the cases, majority of the cases, yes. In certain very rare cases, you will observe it in the tropical conditions as well. Okay. Eastern Australia is an example of a good fishing ground? No. The Peruvian coastline can be an example of a good fishing zone. It is not an ideal fishing zone, but comparatively a good fishing zone. Okay. Is winds go beyond the tropopause? Very rarely. In very rare circumstances, they will go, otherwise, no. Siva, this is live class or not? Take a guess, my dear friend. You never know. It can be artificial intelligence as well. What do you think? These are microorganisms. Yes, phytoplanktons are microorganisms. Yes. Okay. So upwelling basically is when you have the offshore winds which are blowing. In general, these offshore winds, they will carry the surface water along with it, due to which the surface water will be exposed to the surface, and that is what is upwelling, because there is a rising of water. And downwelling is when across a particular coastline, as the water is pushed across the coastline, the water eventually will be pushed into the lower portion, and that is the downward movement, and that is what is downwelling. Okay. Downwelling doesn't have significant amount of benefits. It is the upwelling which will have benefits for the fishing areas. Wind falling will get rains. No, I never said that. Rising of air will always lead to creation of winds, creation of rainfall. Sinking of wind or sinking of air will never end up creating any rainfall. Yes, Vivek, that is correct. Now we come to the portion of ENSO cycles, or what is referred to as El Nino Southern Oscillation. Okay, so here we study about the El Nino Southern Oscillation, and here you have different conditionalities, that is El Nino, La Nina, and also we have the condition of the, when we say you have El Nino, La Nina, you also have a neutral condition in between. So the discovery of this El Nino condition was something which happened as a result of it was a kind of an accidental discovery. When we talk about the region of Peruvian coastline, as per the Walker circulation, the Peruvian coastline, would it receive rainfall or would it be dry? As per the Walker circulation, Peruvian coastline, would it receive rainfall or would it be dry? It would be significantly dry, right? Now, Peruvian coastline would receive summer months or would experience summer months during which part of the year? Generally, it is towards the southern part, southern hemisphere. So it would experience summer months in the month of November, December, January, February, right? That is when it would experience the summer conditions. So generally in the Peruvian coastline, during the summer conditions, you have oppressive weather condition where you have the high pressure as well, which is created over the water body. So you have a sufficient lack of rainfall. Very hot and warm conditions are expected or experienced. Now, what happened actually was that at one point of time, the fishermen of the Peruvian coastline, they suddenly experienced significant amount of rainfall during the month of December, around the time of Christmas. Now, ideally, around the time of Christmas, that is where they would expect summer conditions, lack of rainfall. But once they experienced that rainfall happening across the Peruvian coastline in the month of December, now they thought it to be as a gift of God. And that is where they named that particular condition. When Peruvian coastline would receive rainfall in summer, they would name that phenomena as El Nino, because the meaning of El Nino, it turns out to be a what is referred to as a Christ child, right? So this was referred to as a gift of God. So very soon it became very prominent that across the Peruvian coastline or across the region of the Pacific, you have certain climatic anomalies, you have certain climatic conditions, due to which the Peruvian coastline starts receiving rainfall, and the Australian coastline, which would otherwise normally receive rainfall, Australian coastline would end up becoming dry during these cases. So this condition was regarded as El Nino. Now, that is where it was understood that these phenomena of El Nino, that doesn't happen every year. It happens every 3 to 4 years, or every 4 to 5 years, or 5 to 7 years. Once upon a time, it would happen that rather than being dry, the Peruvian coastline would receive rainfall and Australian coastline would go completely dry. Now, this was something which was a reversal of normal condition. So it was understood And it was concluded that across the Peruvian coastline, you have variation in temperature conditions. You have a significant variation in climatic conditions where it can get rainfall in the Peruvian coastline, and sometimes it can be very dry in the Peruvian coastline. Maybe every 2 to 3 years, you would have one such year where you would receive rainfall. And then for the following 3 to 4 years again, the Peruvian coastline would be dry. Again, it would end up receiving rainfall. Again, it would be dry. So it was referred to as a kind of an oscillation of the weather phenomena. Hence, the name El Nino Southern Oscillation was arrived at. What we refer to it as ENSO. So ENSO basically here refers to El Nino Southern Oscillation. Why the name oscillation? Because it would oscillate between a normal condition where Peruvian coast would be dry and the condition of El Nino where the Peruvian coastline would receive rainfall. Now, later on, climatologists, as they started studying the Pacific Ocean significantly more, they came across another condition which was opposite of El Nino. So that was named as the girl child or La Nina. So you have the condition of El Nino. Sir, you are hanging. Where am I hanging, my dear friend? I'm still standing. I'm not hanging. Are you talking about the video? Video is hanging. I cannot hang. At least not as of now. Okay. The video. Okay. It is a lesser problem then. So here you have La Nina. And then you have the normal conditions. So it was understood that in the region of the Pacific, particularly the region of equatorial and south equatorial Pacific, you would have a condition which would oscillate in between neutral to El Nino every few years, or it would get back to neutral every few years, or it could turn to La Nina every few years. So this change and a kind of an oscillation between different weather conditions, that was referred to as the ENSO cycles. What these ENSO cycles are, what El Nino is, what La Nina is, that is something we will understand. That marking above N, that is basically used in Spanish terminology. That, so if you would write it like this, it would be Nino. It would be pronounced as Nino, El Nino. But here you put that, so the pronunciation goes El Nino. So that is where you have that kind of an annotation which is used. Now, here, this is what was experienced in the region of Pacific Ocean to be observed. Now, the neutral or the normal conditions that generally prevail, so that is the Walker circulation that we have just studied. So this is your Walker circulation. Conditions created due to Walker circulation. Okay, that is the condition created due to Walker circulation. So under neutral conditions, trade winds, what we have studied as the Walker circulation. So neutral conditions are nothing but existence of Walker circulation. So this is basically existence of Walker circulation. So here, under normal conditions, trade winds, they help accumulate warm waters in the western equatorial Pacific Ocean, that is in the region of the western Pacific, that is the Australian coastline, while cold waters emerge in the eastern equatorial Pacific Ocean, that is the Peruvian coastline. These cause rainfall in the region of North Australia, while due to high pressure, there's a lack of rainfall across the western coast of South America or the Peruvian coastline. So this is what is experienced under normal conditions. Experienced under normal conditions. So in this circulation, you will observe that there is a movement of wind from the region of the Eastern Pacific, because in the Eastern Pacific, you have the presence of, or you have the condition of upwelling here. And all the surface warm water is getting accumulated in the region of Western Pacific, and that is where you have sufficient amount of rainfall which is observed, or an average rainfall which is observed across the region of the Western Pacific. And this circulation is fueled by the trade winds. Okay, now sometimes what happens, now again I want you to start observing and following the process of logic here. Again we are getting into a concept. So now you have the condition of high pressure here. So sometimes what happens, let us understand that. You have a condition of low pressure, isn't it? So this is a pressure gradient force. So when you have a pressure gradient force, there is going to be a wind movement. Wind always blows from a high to a low. So here you will have a wind movement, that is the trade wind, and that trade wind will continuously move from the region of the high pressure to the region of the low pressure. Now, due to this movement, or due to this creation of a low pressure and a high pressure, as the winds are moving, can we say that there can be a possibility that these winds, they carry on surplus amount of surface water along with them? We can make that conclusion that this wind movement can carry surface water along with them. Now, surface water is always going to be warmer, isn't it? So as more warmer water is carried in the region of low pressure, what do you think will happen to the accumulated warm water? It will increase, it will stay the same, or will it decrease? What do you think? Just a moment, guys. Is the audio and video available now? Is it clear now, guys? Audio and video is available? Audio is muted? No. Everything is clear? Can we proceed ahead? Video is not clear. It is slightly blurred. Okay, for majority of you, I think it is clear. So we'll proceed ahead. So here, what you observe here is the case that you have a pressure gradient force, and that pressure gradient force will attract or will carry out more winds to the region of that low pressure. Now, as the winds are blowing, they will carry more amount of warm surface water along with them. So the region of that warm water, the area of that warm water, that will increase, isn't it? That will end up increasing. So sometimes what happens is that this region of warm water keeps on increasing. It keeps on increasing. So as this region or the area of warm water, as it increases, what do you think will happen to the intensity of low pressure? Will the low pressure get strengthened? Will it weaken? Or will it not get impacted at all? right? As you have more warm waters which accumulate, we can say that low pressure will get strengthened, low pressure will get intensified. So the low pressure intensifies in certain cases. And as the low pressure intensifies here because of greater amount of accumulated water, it will begin to attract more winds from all sides. So what will happen to the rate of upwelling in that case? The rate of upwelling on the Eastern Pacific, will it increase? Will it reduce? Rate of upwelling. Very good. It will increase. It will be very, very high. So you will have larger areas of upwelling. You will have these cold waters which will spread over the larger areas. Now, what will happen to the wind motion, the speed of wind in this case? If the low pressure has strengthened, the high pressure has strengthened, what will happen to the wind movement? It will become very fast. So, in this case, not only has the wind strengthened from the normal conditions, but the low pressure has also intensified as compared to the normal conditions. So, what will happen to the amount of rainfall received in the region of Australia, Indonesia? Amount of rainfall, will it increase? Will it reduce? It will increase. As compared to normal, the amount of rainfall will get more heavier. What will happen to the dry conditions in the region of Eastern Pacific and Peruvian coastline? Will the dry conditions get converted into further dryness, further warmness, or will that region start receiving rainfall? More dry, right? So when that normal condition intensifies in behavior, that is what we refer to as La Nina. So La Nina conditions overall, when we say La Nina conditions, you have a greater accumulation of warm water across the region of the Western Pacific. The winds, they get much stronger, and the colder waters, they spread quite significantly. So this region becomes significantly colder because of upwelling. So as compared to earlier, the earlier scenario, the normal conditions, this was your normal condition, right? So as compared to normal, if you observe the region of the Central Pacific, can we say that the colder water region has increased because of increased upwelling? Can we say that? Yes. So that is the phase of the La Nina. This is also referred to as the cooling phase of the Pacific because you have a spread of the colder water. So this is your condition of La Nina. La Nina is nothing but a much stronger and much more intensified Walker circulation. So this is your La Nina condition, which is nothing but intensified Walker circulation. And when you have an intensified Walker circulation, that is also referred to as a cooling phase of Pacific. Okay, so when we talk about La Nina conditions, observe that how you will find that there is a greater amount of spread of warmer waters in this region. So La Nina conditions are the conditions where a significant low pressure develops over the western equatorial Pacific Ocean, where while an intensified high pressure develops over the eastern equatorial Pacific Ocean. In a way, it is nothing but an intensified Walker circulation that we achieve. It leads to flood-like conditions across northern Australia, while leading to drought-like conditions across western part of South America, that is the Peruvian coastline, will start experiencing drought-like conditions, whereas the Australian coastline, Indonesian coastline, the Philippine region will receive so heavy amount of rainfall that it will create flood-like conditions in the entirety of the Western Pacific and very dry drought-like conditions in the region of the Peruvian coastline, drought-like. Now, here we have seen that the rate of upwelling, is higher as compared to the normal conditions, isn't it? So observe what happens in a cross-sectional schematic way. Observe what happens in the case of the La Nina conditions. You will observe that if I compare this to earlier situation, let's suppose I have a comparison with the earlier situation here. In the normal conditions, that is the neutral conditions or the normal Walker circulation, you still had some warm water. Upwelling was happening, but still some warm water was present. Now, if you fast forward it to the condition of La Nina, you will find that there is almost no warm water present because you experience greater rate of upwelling. So high pressure will be much more intensified. And here you will observe fair and dry weather conditions. Here you will observe sufficient amount of rainfall which is created. Okay, so that is basically the condition of a La Nina, which is nothing but an intensified Walker circulation. So this is the impact created by La Nina in terms of the global circulation. So here, if you observe the global circulation, you will observe that in the region of the Western Pacific, you have warm water which keeps on accumulating. The colder waters, they spread over that area. And again, you have sinking air conditions in the region of Western Pacific. So under these conditions, if you apply the same logic out of Arabian Sea and Bay of Bengal, which is more likely to form a tropical cyclone? Arabian Sea or Bay of Bengal? Perfect. It will be Bay of Bengal, because Arabian Sea and the entirety of the Western Indian Ocean will experience a sink in the air, right? Sinking air. Now, we will study about the impact on Indian monsoon in detail in the module for tomorrow. But here, just to give you an idea, La Nina is always associated with higher than average rainfall in India during the monsoon months. So this is associated with Why is it so? We will study about it tomorrow. Associated with higher than average rainfall in India during monsoon months. Primarily during monsoon months, but otherwise also it will be always associated with higher than average rainfall. Okay, it is not only the Arabian Sea which is experiencing the sinking air, it is in fact the western portion of Indian Ocean, some portion of southern Indian Ocean as well, some portion of slightly northwestern Indian Ocean as well. There you will have sinking air conditions. Okay, so that is where you have a higher than average rainfall in India received during the monsoon months. Now, after this, I want you to understand difference between a Walker circulation and La Nina. So La Nina is when the Walker circulation becomes much more stronger, much more intensified. So now, when we talk about the other aspect, I want you to concentrate or think about or imagine a kind of a condition that you would have experienced or that you can associate with, a very homemade experiment that you can think about it. Suppose you have a bucket. Let's suppose you have a bucket of water here. Now let's suppose you fill this bucket with water right up till the brim. Now if I actually have a fan here, let's suppose, and this fan is continuously rotating, it is giving wind in this direction. Now, as the water is filled to the brim, can you imagine a scenario where all this water will slightly be pushed aside by the wind? And then can we say that the water keeps on accumulating in this region? Maybe some of the droplets will fall here as well because of the impact of the wind. We can imagine that. I hope there is no issue in imagining that, right? There is a kind of a swelling of water in this region. Some amount of swelling of water, accumulation of water will happen. Now imagine if I remove this fan. Now what will happen? In that situation, will the water still retain an accumulated shape? Will the water continue to retain a kind of an accumulated shape, or will it have a flow back? Obviously, it will have a flow back. That is, that accumulated water will tend to have a flow back. That accumulated portion was present or was kept in that region because of the wind movement. The moment that you stop the wind, that water will have a flow back, isn't it? Now, with that basic concept, let us understand the entirety of the concept of El Nino. So, again, before coming into El Nino, now, for the creation or the movement of the surface water, we have the involvement of trade winds, right? Now, trade winds, if I consider this as ITCZ, now trade winds, they originate and move to the ITCZ from which area? And listen to this portion carefully. ITCZ, the trade winds originate from which region? Which pressure zone? The subtropical high pressure belt, isn't it? So here you have the subtropical high pressure belt. Subtropical high pressure. That can be considered as the origin point for the trade winds. Okay. That can be considered as the origin point of these trade winds. Now, these origin point of trade winds overall, here, understand that this high pressure is created due to sinking of air. We have seen earlier, while we were talking about the trade winds and the permanent wind system, we have seen that just because there is a sinking of air, you have a dynamic high pressure which is created. So in this area, normal conditions mean you have a sinking air, and that is created due to dynamic conditions, not because of thermal conditions. Now, it can happen every 2 to 3 years or 3 to 4 years, it can happen, because think about it, that whichever place you are living in, not every summer season has the same temperature. Few of the summer seasons are much more warmer. Few of the summer seasons are slightly cooler. I'm sure you would have encountered that some of the summer seasons are very warm, some of the summer seasons are very hot, some of the summer seasons are cooler. So it can happen that after a couple of years, 3 years, 4 years, let's suppose this region gets heated. Let's suppose heating happens in these areas. Now, when you have heating which is experienced in that situation, what do you observe? Whenever heating happens, normally air expands and tries to rise up. Normally, that is the condition. Wherever heating happens, the air expands, tries to rise up. Now here, you already have a sinking air. Listen and follow the thread very carefully. Here you already have a sinking air, but the ground is getting heated up in this year. So when the ground or the water body is getting heated up, the air will try to rise up simultaneously. So what do you think will be the impact on the high pressure zone? The subtropical high pressure zone, will it get stronger? Will it get weaker? Or will it remain the same? The subtropical high pressure zone. So the high pressure, will it get stronger? Will it get weaker? Or will it remain the same? Why do you think it will get stronger? All those who have said that it will get stronger, the high pressure will get stronger. Why do you think it will get stronger, the high pressure? Pula, Usna, Kiran. It will get weaker, isn't it? It will get weaker because ideally in this region you had sinking air. Now, as the ground has gotten more heated up or the surface has gotten heated up, there you will have now a counteractive or an opposite force of rising air. So, on the ground surface where you had sinking air, now the impact of sinking will be reduced, isn't it? The impact of sinking will be reduced. So, can we say that high pressure will get weakened here? Right? So, when the high pressure gets weakened here, what will happen to the trade winds? The trade winds were driven by that high pressure. Trade winds were originating from the region of high pressure. So, if that high pressure in itself has gotten weaker, so the trade winds, can we say either they will become very weak or for a point of time they can get absent as well? Can we imagine that scenario where because of the weakening of the subtropical high pressure, it can happen that the trade winds can become absent in a region or can weaken quite substantially, isn't it? So that will be similar to removing the fan from the earlier example that we had seen. So because the winds, the trade winds were carrying the surface water, accumulating it over the region of the Western Pacific. Now, when the trade winds have gotten weaker or have gotten absent, what will happen to that accumulated water in the Western Pacific? Where do you think that accumulated water will go? It will flow back. It will start flowing back, isn't it? So when that accumulated water flows back, it can either come to the region of the Central Pacific, or if there is a significant accumulation, greater flow back, it can even reach the region of the Eastern Pacific. Now, when that happens, that is basically what creates the condition of El Nino. So when we talk about El Nino, so here, let's suppose we talk about the condition of El Nino. So, weakening of high pressure will lead to weakening of or disappearance of trade winds that will, in a way, the accumulated water accumulated warmer waters in West Pacific begins to flow back. Okay, I hope till this point it is clear. So as it begins to flow back, let's suppose there is a greater accumulation. So it will flow back quite significantly. So all the warm water which was accumulated in this region, all that warm water will initiate a flow back and it will come somewhere here. So that is your region of warmer waters. Now this region of warmer water, that is wherever you have that warmer water, it will create a low pressure, isn't it? This will create a condition of low pressure. Now low pressure will now start attracting winds. Winds don't know eastern or western Pacific. Winds only know high pressure and low pressure. Now that you have the low pressure created here, so it will start attracting winds. So the winds now start moving towards this direction. So here the winds will rise up. In the meanwhile, as the winds are coming here, they will be carrying surface water along with them, the surface warmer water along with them. So what will happen to the water temperature in the Western Pacific? What do you think? What will happen to the water temperature in the Western Pacific? It will get colder, it will reduce because of upwelling. Perfect, very good, guys. So this is where it will get colder. So you have cold subsurface water, and you have warm water due to flow back. Okay. Yes, Mushtaba. Sometimes it is contributed by the counter equatorial current also. So that is something which you will observe here. So the wind will move from a high to a low. This will be a high pressure, and this will be a low pressure, right? So here, now as the air rises up, there will be condensation. Significant amount of condensation, and that will cause rainfall in the entire region. And this air will then rise up, will diverge. It will sink in the region of high pressure. High pressure has sinking air. It will sink in the region of high pressure. Here also it will diverge, move in different direction. So can we say that this is a reversal of the normal Walker circulation that we had seen earlier? Can we come to that condition that it is a reversal of the normal Walker circulation? That is what we refer to as the condition of El Nino. So here, in the case of La Nina, we also observed that as the cooling phase of Pacific, because a significant portion of Pacific was cooled down due to upwelling. So here, can we refer to this as the warming phase of the Pacific because the warmer waters are spread over the central and the eastern Pacific? Can we refer to this as the warming phase of the Pacific? Perfect. Good. So this is what is referred to as reversal of normal Walker circulation. Also known as the warming phase of Pacific. Now we'll study about it tomorrow, that how it impacts the Indian monsoon or Indian weather conditions. But generally, El Nino always is associated with less rains or less rainfall in India. Always it is associated with significantly lesser amount of rainfall in India. Till this portion, is this understood? Perfect. Now, what will be the change in weather condition? Can we say that what do you think will happen in Australia? Will Australian coastline now be dry or will it receive rainfall? Very dry. Perfect. What about the region of the Peruvian coastline? It will receive rainfall. Now, it generally happens during the southern summers, that is in the month of November, December, January. So that is when the Australian coastline becomes very dry and the Australian region becomes very dry, it can create drought-like conditions as well. And oftentimes it can also lead to conditions of forest fires or wildfires in Australian desert regions and the surrounding areas because of very dry conditions which are created. Okay, so that is the basic perspective of El Nino. Now, if I ask you a question that we have not covered yet, which generally you cover in the portion of the aspect of current affairs, but I want you to think about it and I want you to get an answer or a reply about it. And that is when we talk about the climate change and global warming. Now, climate change and global warming will induce greater events or greater frequency of La Nina or greater frequency of El Nino. What do you think? Climate change and global warming. Good. It will always lead to El Nino. Why? Because the warming phase of the Pacific will always be accelerated. And with the rise of the sea surface temperature, as the Pacific Ocean starts to get warmer, there will always be a natural weakening of the subtropical high pressure belt, due to which the trade winds, they will start getting weaker in general. So that is why with the rise in sea surface temperature across the globe, the events of El Nino, they are becoming much more frequent. Earlier, they would be experienced every 5 to 7 years. Now they are experienced much more frequently. Okay, so during the El Nino, observe that the warm water which was accumulated in the Western Pacific, that begins a flow back and that accumulates in the region of the Central and the Eastern Pacific. So due to weakening of trade winds, the accumulated water across the Western Pacific starts to flow back, leading to redistribution of warm and cold waters. Due to this, there are changes observed in the weather conditions, leading to drought-like conditions near Australian coast while causing floods across the Peruvian coastline. Okay? Now, this is basically the circulation induced by El Nino. Observe the spread of the cold, warm waters across this entirety of the stretch. The warm waters are stretching significantly. Observe the circulation created by this. You will observe that in the Western Indian Ocean, there is a creation of a low pressure. Southwestern Indian Ocean, and even in the equatorial and slightly northern Indian Ocean, also there is a low pressure sometimes. Now, in these conditions, which area will receive more formation of tropical cyclones, Arabian Sea or Bay of Bengal? What do you think? Good. This time it will be the Arabian Sea. So this will favor the formation of a tropical cyclone in the region of Arabian Sea, significantly with a greater frequency. So this year, we have the development of the El Nino conditions this year, which will get further accelerated and exaggerated next year. So that is why these years you will observe the greater formation of cyclones. It is not to say that Bay of Bengal will not experience cyclone. Bay of Bengal has got a basic oceanic feature which will always promote the formation of a tropical cyclone in this region. But you will also observe greater formation of tropical cyclones in the Arabian Sea as well. Okay, I hope that is understood. So here is a relation between El Nino and the Indian monsoon. So observe 2004 to 2013. So 2004, you had an El Nino year and we had a drought condition. We received only 88% of the average expected rainfall. Only 88% was received. 2005 was a neutral or a normal condition. We received 101% normal rainfall. 2006, neutral condition, normal conditions, we received 103%. 2007, we had La Nina conditions, excessive rainfall, 110%. Then 2008, La Nina persisted, but its intensity reduced. We received 105% of rainfall. 2009, El Nino prevailed again, and this was a very strong El Nino. We had a severe drought-like condition in 2009, and that is why Indian economy in 2009 and 10 suffered because of the simultaneous occurrence of drought, farm and crop failures. Also, you had a global economic crisis. It was that, and if you really want to interlink the various subjects, that is what led to a kind of a lending crisis by the banks, where banks were told to give money to anyone or everyone who was interested. And that is how you had the entire NPA crisis, that, and the twin balance sheet problems that you would have studied in your economics and economic survey, that was induced in this year. So El Nino, La Nina, they have a larger impact on Indian economy and Indian food security as well. 2010, it reverted back to La Nina, but because it was reverting from an El Nino condition, so you had normal rainfall. 2011, La Nina prevailed for the second time, so observe, you have 104%. Like that, El Nino, La Nina is something which started or which impacts the amount of rainfall. For the past 3 years, we had been experiencing the continuous occurrence of La Nina, which is a very rare phenomena. And that is what is also referred to as the triple dip La Nina. When you have the La Nina condition prevalent significantly, that is what is the triple dip La Nina. Now, this year, it is changing to neutral to El Nino characteristic. Next year is projected to be a strong El Nino. Even this year, from the month of September onwards, there is an expectation that the amount of rainfall would reduce because the Pacific is heating up. The Pacific is already warming up. Okay. Now, that is the aspect of El Nino and monsoon. So let us take a look at the question. I'm sure if you study this or read this question carefully, you will understand or you will be able to solve the question as well. So La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? So read the question statements carefully and come to the solution. La Nina is characterized by unusually cold ocean temperatures, whereas El Nino is characterized by unusually warm ocean temperatures. El Nino has adverse effect on southwest monsoon, but La Nina has no impact. So again, I would say, read the statements very carefully and then arrive at your answer. Very carefully. Anurag, it will lead to low pressure condition in the Western Indian Ocean. Good, Somil, correct. Increased heat waves in India were also a development of El Nino. Yes. So heat waves in India, they are impacted by many phenomena, but then this El Nino has also contributed to it. So as expected, majority of you have not read the question statement carefully. You have not read the options carefully. So here, let me read the question statement carefully for you, but I hope you don't set this expectation that I will read the question statement for you even in the prelims. I hope you understand you will have to do it on your own in the prelims. La Nina is characterized by unusually cold ocean temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in the equatorial Pacific Ocean. Is that correct? Can that be correct? Anyone who says that is correct? No. It is just this one statement that basically one word that UPSC played with. And what happens is, majority of the times when we see the statement, we feel the rest of the words are correct. So this also would be correct. Have we talked about Indian Ocean at all? Have we talked about Indian Ocean at all till now? No. Here, if it would have been Pacific Ocean, this would have been a correct statement. But it is Indian Ocean, right? So this is incorrect. Second statement, El Nino has adverse effect on southwest monsoon of India, but La Nina has no effect on monsoon climate. Have we seen that La Nina increases the amount of rainfall received in India? Is that understood? So will that statement be correct? Absolutely not. So that is why here the correct answer is D, neither one nor two. So that tells you how UPSC plays the tricks. Okay. And it is in these questions where you end up losing the race. Understand, and I always repeat that you will. Which portion of the statement is not clear? See, this is the problem which also happens in the prelims paper. Sometimes we are so convinced that we are correct, we are not ready to see the basic things here. Here, the second statement says La Nina has no effect on Indian monsoon climate. In the earlier case or in the earlier situation, have we seen La Nina is associated with excess rainfall in India? Khushi, Lakshmi? No, we have not seen that. If I show you the statement, have we seen that La Nina is associated with higher than average rainfall during the monsoon months? Have you seen this? And further on, to add to that, have we seen that La Nina causes 110% rainfall here, 104% rainfall here? Have we seen it is associated with excess rainfall? Right? Is that understood now? It is not a morning class where I expect that you would close your eyes and sleep in the process. But then I expect you to be aware in the evening sessions. Okay? How El Nino causes lesser rainfall, why El Nino causes lesser rainfall, we'll study about it tomorrow when we make ourselves aware of the aspects of mascarene high pressure belts, which is the driver of the Indian monsoon. So it is the weakening and the strengthening of the mascarene high pressure. Mascarene Islands is a region in southern Indian Ocean which develops a high pressure zone that is a driver of winds for the Indian monsoon. So we'll study about it tomorrow. Okay. First part of second statement is correct. Second part of the first statement is correct. Okay. Is that understood? Good. La Nina is a strengthened form of Walker circulation, Sarita. It is when the Walker circulation gets much stronger. Now, then we come to what is referred to as the Indian Ocean dipole. Now, dipole, it tells you the existence of two different polarity. Now, in the case of Indian Ocean, now Indian Ocean on the western part is surrounded by here, Indian Ocean if you consider, so Indian Ocean on the western part is having the landmass of the Horn of Africa. Here, it is having the Horn of Africa here. And in the eastern part, it is surrounded, the eastern Indian Ocean is this particular portion. So the eastern Indian Ocean is actually bounded by many different islands, right? Now here, when the portion of the eastern Indian Ocean is surrounded by many different islands, so water will be trapped within these islands. There won't be a free movement of water. So when the water is very closely surrounded by land, can we say that there will be impact of the heating of land on the water as well? Right? So can we say that the water can get heated up because of the heating of the land? Right? So that is something which impacts the sea surface temperature between the eastern and the western Indian Ocean. Even if that difference of temperature is 0.1 degree Celsius or zero point 0.2, 0.3 degrees Celsius, that is enough to induce a kind of a comparative pressure difference between the eastern and the western Indian Ocean. Sometimes it can also happen that this region of Africa, the Horn of Africa, that is around Eritrea, Djibouti, Somalia, they get so much heated up that even the water here gets heated up. So that difference in temperature between the western part of equatorial Indian Ocean and the eastern part of the Indian Ocean, that is referred to as Indian Ocean dipole. So Indian Ocean dipole is also called the El Nino of the Indian Ocean. Now it is defined by the difference in temperature between two areas or two poles of the equatorial Indian Ocean, hence a dipole of the Indian Ocean, a western pole near the Somalia coastline, that is the African coastline, and an eastern pole in the eastern Indian Ocean, south of Indonesia. It is a sea surface warming phenomena. And that sea surface warming phenomena basically is what attains different temperatures at different portions of the Indian Ocean, and different portions of Indian Ocean heat up at a different rate because of properties of the nearby landmass that is impacted by the heating of landmass, prevailing wind patterns, and sometimes even oceanic circulations. This induces a thermal pressure difference across the eastern and the western end of the Indian Ocean. This thermal pressure difference will induce an atmospheric circulation, and that atmospheric circulation, which will be initiated in the Indian Ocean. So imagine, earlier we had seen an atmospheric circulation initiated by the Enzo cycle. Now imagine if there is a fresh circulation, a new independent circulation initiated in the Indian Ocean, can we say it will end up interacting and counteracting the impact of Enzo? Right? So that is where it influences the impact of Enzo cycles across the Indian Ocean. It can either exaggerate the impact of El Nino or La Nina, or it can counter impact the effect of El Nino or La Nina. This is a sea surface temperature which is measured on a daily basis. On a day-to-day basis, you measure what is going to be the sea surface temperature there. And whenever you have a difference in sea surface temperature up till a depth of around 50 meters, so whenever you have a surface temperature which differs by 0.2, 0.3, 0.4 degrees Celsius, that will create a thermal pressure difference, and that thermal pressure difference will induce a new circulation. So imagine if in an area, due to Enzo circulation or Enzo conditions, imagine if this is the circulation in an area. Right. Now, due to the heating and the cooling of the surface, imagine there is a fresh circulation which happens in this area. Now, can we say that the impact of the Enzo circulations can be counteracted or can be further exaggerated by the presence of Indian Ocean dipole? Right? So this will also end up having different phases. The Indian Ocean dipole also has got different phases. It has got what is referred to as a positive, a neutral, and a negative phase. So ideally, it is always important for you to identify which would be the neutral case. Then variation from the neutral case is something which can always be understood. So when you talk about the normal condition or a neutral case, here, if we talk about the neutral case here, so basically, this portion is too lengthy. Shubham, my dear friend, if you have understood this portion, that in itself is something that is beneficial, because majority of the candidates, they are always having a doubt and they are never able to get to the depth of El Nino, La Nina, and Indian Ocean Dipole, you will not find in the books at all. In majority of the books, you will not find Indian Ocean Dipole, you will not find MJO. So I understand it is lengthy, but it is important for your examination. So you can have two choices. Either ignore this and take a bet that UPSC will not ask this, and in that case, you are basically playing on the bet, or try to understand it, try to gather it. It always follows a simple logic. The moment you are trying to learn it, the moment you are trying to mug it up, you will never be able to understand it. So, in the neutral case, here, understand this. When we consider the Eastern Indian Ocean, by the way, is far away from the Western Pacific. So, don't get confused between the Eastern Indian Ocean and the Western Pacific. These are a good 1,000 kilometers and plus away from each other. Now, in this region, can we say that the water is basically trapped in between the various different islands? You have the sea and you have multiple different islands in between. Now, that will in a way inhibit the circulation of water, and the land will always get significantly greater amount of heat. So when the land gets heated up, that heat will be gained by the water nearby as well, isn't it? So under normal circumstances, the temperature of the water in this will be higher than normal open water, lower than normal open water, or will be same as what you observe in the Central Indian Ocean. What do you think? Under normal circumstances, it will always be higher, right? Because it is getting heated due to the influence of the land areas. So that is where you have the normal conditions. So this gets heated. Now, when you have a heated water, it will attract winds from all directions. It will attract winds. Now, what will happen in the Western Indian Ocean? Upwelling or downwelling across the African coastline? What do you think will happen in the Western Indian Ocean? Upwelling, perfect. So here you will experience upwelling to happen because the winds are going to move offshore attracted by that high heated water. That heated water will create a low pressure. So that will create upwelling. So you will have colder waters here. So that will be your high pressure. So we will have a circulation of wind pattern here. We will experience a circulation of wind pattern here. So this is your neutral or the normal case. This is your normal case. Here also you have the three phases: normal, negative, and positive. Normal is generally associated, or the neutral case, why it is associated with less or more rainfall, we will study tomorrow. But normal case is associated with lesser than average rainfall in India during the monsoon season. So this is your neutral phase. So this is where you have low pressure in the region of the Eastern Indian Ocean, high pressure due to upwelling in the Western Indian Ocean. So this is associated with less than average rainfall in India. Now, just like the earlier scenario of Enzo cycle, associate here also. When you will observe this particular movement, let's suppose you observe this particular movement. Now you have low pressure, winds are coming to the low pressure. So when the winds are coming to that low pressure, they will further start pulling up the warm surface water. So what will happen to the region of that low pressure? Can we say that the low pressure will get extended, expanded? You will have more warm waters in the region of the low pressure. So that will always lead to more upwelling, right? So you will have more upwelling in the Western Indian Ocean. So we can say that the normal phase can get intensified. That will be associated with the negative phase of IOD. So negative phase of IOD is an intensified normal phase. Intensified normal phase. Okay, associated with very less rains over India. Why associated with less rains? That has got to do with the creation of a mascarene high. So we will study about it tomorrow. Again, I keep on repeating because continuously I see those questions that why and why. So that is basically here you will have the case of the associated with less rains over India. Okay. Now, in this year in my state PCS mains, I make slightly wrong diagram. Instead of Indonesia, I show Andaman region is low pressure. Andaman region is incorrect, but if you have shown a slightly southward portion of in the region of Nicobar Islands, if you have shown low pressure, that will still be okay. Okay. And in the mains examination, they have a greater tolerance for that. So again, by the way, in the neutral phase, out of the region of Arabian Sea and Bay of Bengal, where is it that you will experience greater occurrence of tropical cyclone? In the neutral phase? Very good. Bay of Bengal. Why? Because in the Western Indian Ocean, you have sinking air. In the case of the negative phase, where is it that you will experience greater occurrence of tropical cyclones? Very good. Again, Bay of Bengal, because here you have high pressure, you have cooler than normal water because of greater upwelling. Now, then we have the case of the positive. Now, sometimes what happens is basically the African coastline, that is the Somalia coastline, and also the Arabian Peninsula, that is the region of the Arabian Peninsula around Persian Gulf, all the way around Gulf of Aden. Now, these areas, they get very heated in certain years. So that is where they will have an impact on the nearby water body as well. And that impact on the water body will create a low pressure because of warmer water body getting created. So it will start attracting winds towards that low pressure. So it will attract winds towards that low pressure, and that is where you achieve a kind of a circulation. So now this is the region where you will experience upwelling. So this is what is the positive phase. So positive phase is the reversal of the normal or neutral IOD. Neutral IOD. In this phase, where is it that you will expect greater amount of tropical cyclones to be created? Arabian Sea or Bay of Bengal? Perfect. Arabian Sea. So if I ask you, in all the various different climatic conditions that we have seen, there are only two conditions where we have seen that there is a greater probability of cyclones in Arabian Sea. One is this positive phase of Indian Ocean dipole. What is the other positive phase? Or what is the other condition where we have seen that Arabian Sea can have a probability of cyclones? El Nino, right? So these are the only conditions, or these are few of the conditions where you will naturally expect greater occurrence of cyclones in Arabian Sea. But what I want to get at it is, in majority of the cases, you will observe these cyclonic formations to happen in Bay of Bengal. So all of these are your accumulated reasons why more formation of cyclones in the region of Bay of Bengal. Okay. Now, this will have a positive impact on Indian monsoon. Impact on Indian monsoon. Always understand that this Indian Ocean dipole phenomena, in majority of the cases, it is independent of the ENSO cycles. So it can counteract the impact created by the El Nino or La Nina. For example, in the year 97-98, the Pacific was heated up beyond the expected proportion. And the El Nino conditions which were created were amongst the strongest in the last century. So, India was expecting a severe drought like condition. India was expecting that we would receive somewhere around maybe 70% of our expected rainfall. But India ended up receiving close to around 97% of the expected rainfall. Later on, as the climatologists and the meteorologists further explored, they found out that India received higher than average rainfall, or basically the impact of El Nino was counteracted because there was a positive IOD simultaneously which existed, which weakened the impact of El Nino over the Indian subcontinent. So, this Indian Ocean dipole can weaken or can strengthen the impact of the ENSO cycles overall. Always get that clear. Okay. Positive phase will occur because there will be significant amount of heating in the region of Somalian coastline, and why Somalia would get heat and Indonesian island will get colder. It is not that the Indonesian island will get colder. Please understand, again, I would repeat, even if let's suppose across the Indonesian islands, the temperature, let's say, is 25.5 or 25.9. And across the region of the Somali coastline, the temperature is even 26.1. Even that difference of temperature is more than sufficient to induce a significant pressure gradient. Okay. So that is basically the aspect of the Indian Ocean dipole. Now, UPSC had asked a question from this in 2017 as well. Let us take a look at the question. So, with reference to the Indian Ocean dipole, sometimes mentioned in the news while forecasting Indian monsoon, which of the following statements is or are correct? IOD phenomena is characterized by a difference in sea surface temperature. IOD phenomena can influence an El Nino's impact on the monsoon. Bhagya basically understand that the ENSO cycles, the impact they can have on the Indian subcontinent, they can always have or that can be counteracted by the conditions of Indian Ocean temperature. Yes, Somile, correct. Very good, guys. Beautiful. Very proud. So here, majority of you have given the correct answer. So IOD phenomena is characterized by a difference in sea surface temperature between tropical Western Indian Ocean and tropical Eastern Pacific Ocean. Tropical Eastern Pacific Ocean is where? In the Peruvian coastline. Indian Ocean dipole is the condition between the two sides of the Indian Ocean itself. So the first is incorrect. Second, an IOD phenomena can influence an El Nino's impact on the monsoon. This is correct. So the correct answer will be 2 or B2 only. Okay? I hope that is understood. Right? Now, then we come across what is referred to as a MJO or Madden-Julian oscillation. Right? So, okay. So why the first statement is incorrect? So, when you take a look at the first statement, my dear friends, IOD phenomena is characterized by a difference in sea surface temperature between tropical western Indian Ocean and tropical eastern Pacific Ocean. Indian Ocean dipole, even if you have not studied about Indian Ocean dipole, can it represent the difference between the Pacific Ocean here? Have we talked about the Pacific Ocean? Where is the tropical Eastern Pacific Ocean? Tropical Eastern Pacific Ocean represents the Peruvian coastline. So this has to be Eastern Indian Ocean. The earlier question that we had seen had a similar catch in this. So rather than Pacific, it has to contain Indian Ocean. Is that understood? Equatorial region is included within the tropics itself. Is that understood? Okay. What happens in Indonesia in case of La Nina and positive IOD? It will receive average rainfall, normal rainfall. Uni, what is not understood? La Nina and positive Indian Ocean dipole can happen. Yes, you have excessive rainfall as happened in the year 2021, and you had India receiving close to around 109% of the expected average rainfall. Okay. Peruvian coastline is not understood. Do you know where Peru is? Peruvian coastline here refers to the coast of Peru. Peru. You don't know where Peru is? Okay. My dear friend, kindly take a look at the map. Peru is in South America. So that is what I had told you to do yesterday. See, Peru is in South America. It is across the coastline of South America. And how have you been handling the entire discussion about the Peruvian coastline that we have been having? This is the Peruvian, this is where Peru is. Peru is a country. I hope we are aware of that. Or is that not understood? Where Peru is a country, my dear friend. Okay. Okay. Pratik, revise as much as possible. Shivaji, what you have as a counteracting impact is that let's suppose El Nino conditions are present where they are present, or Enzo conditions are present in the region of the Pacific Ocean. But because of their circulation, they will have an impact on the Indian Ocean as well. If I take you back to this slide, you will observe that in this El Nino circulation, you will have a kind of an impact created here as well, okay, over the Indian Ocean due to the circulation. But if let's suppose in this case a negative IOD develops, so negative IOD means here you will have the simultaneous development of low pressure. So wind will start to or try to rise in this particular portion. So won't it impact the circulation created by El Nino? It will always impact, right? So that is how they can counteract or they can add to the impact created. Okay. It is confusing, it is difficult, it is very hard. I understand that. That is why we have been covering that. There is no escape from the fact that it is difficult. Nobody is saying that this is very easy. I'm just saying that if you follow the logic, it is something which is to be understood. I'm not saying that it is the easiest that you will find in the entirety of the world. Okay. So this is basically something that is required for the examination. That is why you study it, as simple as that. Okay. If you have a confusion between low pressure and high pressure, have you revised the portion? Most of you are finding it difficult. I'm sure there would be some or the other aspect which you have not revised. kindly do the revision of it. Again, I will repeat, this is not the portion of your history or your portion of polity, where if I have not covered the previous portion, I will be easily able to understand the next portion. This is a subject which is interlinked with each other. Each of the chains, they get interlinked with each other. So if one of the chains is weaker, the next structure will automatically be very, very weak. Okay, so please understand that if one by one you and all the various logics that we are applying, all the various processes that we are applying, they are driven by very simple processes of heating, cooling, high pressure, low pressure, and the wind movement. If that portion is clear, you can understand every aspect of it. If you have some amount of doubt or some amount of hesitation that why low pressure, why high pressure, sometimes I see low pressure, sometimes I see high pressure, whether wind will go to high pressure, whether wind will go, if you have doubt in that, trust me, all these portions will be hodgepodge. You will never be able to understand any of that. Okay, so please go back, revise everything, especially the first two modules of climatology. I have been spending a lot of time. I have taken it very, very slow. That is why in the 14th lecture we are still in the ninth module, and we won't be able to complete ninth module here or the 10th module even today. Okay, so please understand. Both Arabian Sea and Bay of Bengal for the formation of a tropical cyclone, in the conditions of a normal Walker circulation, in the condition of IOD, in the condition of La Nina, you will observe that when you have in the region of Arabian Sea a sinking air column, you will never be able to observe a low pressure created. Hence, Arabian Sea in those conditions won't be experiencing any tropical cyclone. No, Sakshi told you simply it is. I'm sure many of you are not even looking at the portion of the additional reading material, nor are you referring to the PPTs. You are simply getting up, sitting in the class, and thinking that this portion will be understood just like you understand the portion of a money bill or a portion of an MP and MLA. So, or let's say industrial revolution. But this is not that particular subject. Okay. Yes, today, how can we proceed further today, guys? Won't be able to proceed today further. Yes, MGO we'll do tomorrow, along with the portion of the Indian monsoon. Enzo cycle consists of the events of El Nino, neutral circulation, and La Nina. That circulation or oscillation between different conditions, that is what is El Nino southern oscillation. El Nino is one of the conditions which are experienced. So I'm sure you won't be facing that much amount of issue in understanding the basic concepts. So many of you, I see you are able to follow the concepts easily. Many of you, you are not able to digest that, and despite taking it very slow. So positive phase of IOD. Vivek, you are continuously asking the question how Western disturbances impact positive IOD. Vivek, do one thing while I'm replying to the other questions. Give me an answer of what do you mean by Western disturbances. Please give me a reply of what do you mean by Western disturbances. I will give you the answer. And Mayank, positive phase of IOD is created sometimes when you have a significant warming of the Horn of Africa and the Arabian Peninsula. So that warming will end up warming the nearby water body as well. So that is what will create a positive IOD. Only by having PPT as notes is it already like it is already like a whole book. Yes, you can revise with the PPT itself. Pooja, in previous question, unusually warm, unusually cold, will it be correct? No, yes, it can be taken as correct. And that rising air from Mediterranean Sea. So, what more? See, it is not that Western disturbances will create a positive IOD. Positive IOD can have an influence in the movement and existence of Western disturbances, because Western disturbance, why will you have rising air in the region of Mediterranean Sea? Get that answer as well. And low pressure develops that sun moves north. Okay. Recorded lectures along with the additional reading materials, do that based